Alright, this video will show you how to calibrate the video of the yo-yo and to analyze the motion. So let's go open file and we'll choose this yo-yo disk 2. So here's our first frame of the video, and we can have a quick look at the video here. The yo-yo falls, and as it falls it spins because it's attached to a string. And so it's a lot like a real yo-yo in that it's a disc that's attached to a string, and as it falls the disc rotates. Okay, so the first thing we want to do is calibrate this, and we're told that it's shot at 29.97 frames. We're given some information about the disc here, and we're told that that distance between these two yellow lines is 1 meter. So let's first check the frame rate. So the frame rate is set at 29.97, which is as it should be. And this doesn't have that many frames, so we don't need to worry about changing the step size. It's going to be manageable to track this. Okay, the next thing we want to do now that time is sorted is we want to tell the software how large the image is. And so to do that, we choose calibration stick, as you just saw me do. So we go to new calibration stick, and once we've done that, we hold down shift, and we can click at the top corner of this yellow line here, and then at the bottom corner of this yellow line here, and tell the software that this is 1 meter. So we'll change that to 1, and then we'll just move that out the way like this. So now the software knows that that blue line is 1 meter long, and so it now understands distance in our video. Alright, now what we want to do is track the motion of the center of mass of this disk as it falls. So we're going to create a point mass, and then we'll click here and we'll change the name here to center of disk, and then we will define some properties of this disk. So it's some useful things that we want to associate with the disk is the mass. So it's not 1 kilogram, it's 0.487 kilograms as it says here. And we also want to tell it what the radius is. So we'll add a new parameter and we'll call that radius. And then we'll give this the expression, and it's going to be half of 15.15 centimeters. We want it in meters, so let's go to the calculator here. And so we go 0.1515 is 15.15 centimeters in meters, and we'll divide that by 2, and we get 0.07575. So this should be 0.07575. And then we can close that. So now we've defined everything. Now we can hold down shift, and that changes our cursor to a crosshair, and we're going to just click on this red dot in every frame. And there aren't too many frames in this video, so we can do this manually. The software can do this automatically for you, but this is not so tedious. It's quite short. And that's the last frame. So now we've tracked all of the frames. So at this stage there are a number of things that we can do. So we can change this to the vertical displacement, so the Y position. Oh, in fact, one thing that we forgot to do, but we can still do that now. So I'm going to skip ahead to the last frame. We want to tell the computer what vertical position is 0. So I'm going to add some axes here, and I'm going to move the origin down to the last position that I tracked. So now that last position is considered 0, and the vertical position, so what we call Y here, so it starts off here 0.773 above that final point, and as we go forward frame by frame we see that it falls and its height decreases. That's going to be useful for establishing the gravitational potential energy at all the points. So the first interesting information that we can extract here that will allow us to determine the acceleration is a velocity time graph. Note that we're dealing with vertical velocity, so we want y component of stuff. We're not interested in what's going on horizontally. You can see that it varies a little bit horizontally, but that doesn't matter. So you can see the vertical velocity increases in the negative direction as it falls. So this by default considers downward to be negative. Okay, so again here, what we're trying to find here, the useful quantity is the acceleration, and we can find that by going to View and going to Data Tool, and here's our line, and you can choose Analyze and Curve Fits. Oops, Analyze and Curve Fits, and you'll get a line of best fit, which is shown here in pink. And the line of best fit has this equation, y equals mx plus c, which in this is expressed as vy, which is our vertical, our y variable. A is the gradient, t is our x variable, and b is the y-intercept, which is not so interesting in this case. But a is interesting because that's the gradient of this. That's how quickly the vertical velocity changes. That's our vertical acceleration. So we can read that off here, and it's about negative 6.63 meters per second per second. Okay. And remember to copy all these things over. You just go to Edit, Copy Image, Plot View, just to show what the velocity time graph looks like. Okay, so that's the calibration and how we plot the motion of the center of mass. So in the next video, I'm going to show how to... No, in fact, in this video, I'm going to show you how to analyze the energy here as well. So for this thing, so we have here a kinetic energy function. So you can see that the kinetic energy of the object as it falls increases as it gets faster and faster. We want to check how that compares with the potential energy, but potential energy is not one of the options here. So we're going to define a new function, and under data functions, we're going to add potential energy. And it doesn't like spaces, so I'm going to leave it without spaces. I'm going to add the unit at the end as well. And the expression for the potential energy is going to be mass. Is it mgh basically? So mass times 9.81. And the height above 0 is just y. Oops, I'll do times y. Times y. Enter. So to edit either of these, I just double click on them and that allows me to edit them. So now I have the potential energy function here. I can look at that, and you can see that the potential energy decreases as it falls. Meanwhile, the kinetic energy increases as it falls, but you'll notice that they don't quite match up the numbers. And so in the next video, what we're going to do is analyze the rotation of the object as well, which adds a couple of new steps.